Every day, millions of people open ChatGPT or another AI and ask a simple question. Some ask it to write an email, others ask it to solve a problem, explain a difficult idea, or help with homework. A few seconds later, the answer appears. It feels so fast that most of us never stop to think about what just happened. We type a few words, AI replies. It almost feels like magic. Because it feels so easy, it's also easy to believe that the machine understood everything on its own. But that's the biggest illusion of all. The answer on your screen didn't begin a few seconds ago when you pressed enter. It began years ago, long before you ever opened this website, long before millions of people even knew AI existed. Every answer you receive today is the final step of one of the biggest human projects ever built. Most people imagine artificial intelligence as one incredibly smart machine. In reality, it is more like a huge city. Every part of that city has a different job. Some people teach AI what words mean. Others teach it how conversations work. Some build the computers that make everything possible. Others spend their days looking for mistakes before you ever have a chance to see them. There are engineers, researchers, electricians, factory workers, programmers, security teams, cooling specialists, hardware technicians, and many more. Most of them will never become famous. You'll never see their names when AI answers your question. But without them, that answer would never appear. Imagine walking into a theater just as the curtain opens. The lights come on. The actors begin their performance. Everything looks effortless. What you don't see are the months of rehearsals, the people building the stage, the sound engineers, the lighting crew, the costume designers, and hundreds of other people working behind the scenes. AI is very similar. The conversation you see is only the final performance. Almost all of the work happened long before you arrived.
That's why so many people misunderstand artificial intelligence. They think they are talking to a machine. In reality, they are seeing the result of millions of human decisions connected together. Someone decided how the AI should learn. Someone corrected its mistakes. Someone built the computers that process your question. Someone keeps those computers running every hour of every day. Someone makes sure the system stays safe. Someone updates it. Someone fixes it when something breaks. The AI may be the voice you hear, but behind that voice is an enormous network of people doing jobs that most of us never even think about. And here's what makes this even more surprising. Every day, we hear people asking whether AI will replace humans. It's one of the biggest technology debates in the world, but almost nobody asks the opposite question. How many humans does it actually take to make AI work? The answer is far bigger than most people imagine.
Behind every response is a chain that stretches across research labs, giant factories, massive data centers, office buildings, and homes all around the world. Millions of people have helped build the system that now answers your questions in seconds. Once you see that hidden world, it's impossible to look at AI the same way again. The chatbot on your screen suddenly becomes only the smallest visible part of something much bigger. And the deeper you look, the more surprising that hidden world becomes. It all starts with the people who taught AI its very first lessons. Most people believe AI became smart because it read the internet. That's true, but only partly. Reading billions of web pages gave AI information, but information alone isn't enough. Imagine giving every book in the world to a child. The child would still have no idea which facts are true, which opinions are reliable, what sounds polite, or why one answer is better than another. Reading is only the beginning. Learning is something very different. AI had the same problem. It could collect huge amounts of information, but it couldn't understand what humans actually wanted. It didn't know the difference between a helpful answer and a confusing one. It didn't know when a joke was funny or when it was offensive. It didn't know that one word could have different meanings depending on the conversation. Someone had to teach it, and that someone wasn't another AI. It was people. Lots of people. Long before ChatGPT became one of the fastest growing apps in history, thousands of workers around the world were already spending their days teaching machines. Their jobs didn't look futuristic. Most of the time, they sat in front of ordinary computer screens doing work that seemed almost repetitive. One task might ask, "Is there a cat in this picture?" Another might ask, "Which answer sounds more natural?" Then another, and another. Thousands of tiny decisions every single day. One person might spend hours drawing a box around every traffic light in hundreds of photos. Another might read conversations and choose which reply felt more helpful. Someone else might label emotions in a sentence, deciding whether it sounded happy, angry, worried, or sarcastic. On their own, these jobs don't seem very important, but together they became the foundation of modern AI. Every small correction was another lesson. Every labeled image was another example. Every comparison helped AI understand humans a little better. Imagine teaching a child what a dog looks like. You don't show one picture and stop. You show hundreds of different dogs. Big dogs, small dogs, black dogs, white dogs, dogs running, dogs sleeping, puppies, old dogs. Eventually, the child stops memorizing individual pictures and starts recognizing the pattern. AI learns in a similar way. It doesn't suddenly understand the world.
It slowly discovers patterns by seeing enormous numbers of examples that people have already organized for it. That's why human work is still so important. AI doesn't magically know what is correct. It learns from choices that humans made first. Even today, when AI seems incredibly smart, it is still building on lessons created by millions of people over many years. Some of those people worked for large technology companies. Others worked for specialized data companies. Many worked from home. Most never met the engineers building the AI systems they were helping train. They simply completed task after task, often without knowing how those tiny pieces would eventually fit together. Yet, without their work, AI would struggle with even simple questions. It might confuse a bicycle with a motorcycle. It might misunderstand basic emotions. It might produce answers that feel awkward, confusing, or completely wrong.
Every conversation you have with AI still carries traces of those invisible teachers. Their names are unknown, their faces are invisible, but millions of their decisions live inside every answer you receive. And even after AI learned to recognize pictures, understand words, and organize information, one enormous challenge still remained. Knowing facts is one thing. Holding a natural conversation with another human being is something completely different. Teaching AI to do that would require an entirely new way of learning. Knowing facts doesn't automatically make someone good at having a conversation. You can memorize every word in a dictionary and still struggle to explain a simple idea. You can read thousands of books and still not know how to answer a question in a way that feels clear, friendly, and useful. AI faced exactly the same problem. After learning from enormous amounts of text, it knew many facts, but it still didn't understand what people actually expected from a conversation. Sometimes it gave answers that were technically correct but impossible to understand. Sometimes it repeated itself. Sometimes it confidently gave completely wrong information. Other times it misunderstood the question altogether. It had knowledge, but it lacked judgment. And judgment is something that is incredibly difficult to teach. So researchers created a completely new stage of training. Instead of simply feeding AI more information, they began teaching it how humans prefer to communicate. This wasn't done by another powerful AI. Once again, it was done by people, thousands of them. Imagine asking 10 different people the same question. How do I start investing? Every person gives a slightly different answer. One explains everything in simple language. Another writes a long technical explanation. Someone else forgets to mention the risks. Another gives advice that sounds confident but isn't actually correct. Now imagine another group of people reading all of those answers and choosing which one they would rather receive themselves. They aren't writing new information, they're making a judgment. Which answer is clearer? Which one is more honest? Which one actually helps? That simple process became one of the biggest breakthroughs in modern AI. Human reviewers compared answers over and over again. They ranked them. They rewarded the better ones and rejected the worse ones. Slowly, AI began recognizing patterns. It learned that people usually prefer answers that are clear instead of complicated, honest instead of overconfident, helpful instead of impressive, safe instead of dangerous. Every comparison became another lesson. Every ranking became another step toward sounding more human. This process happened millions of times.
Imagine trying to teach someone how to become a great teacher. You don't simply hand them a textbook. You watch them teach. You point out mistakes. You explain how they could improve. Then they try again. That's exactly what happened here. AI answered. Humans evaluated. AI improved. Then the cycle repeated again and again and again. Eventually, something remarkable happened. The machine didn't just produce information anymore. It began producing conversations that felt natural. People could ask follow-up questions, change topics, admit they were confused, ask for simpler explanations. AI became better at following the flow of human thinking because humans had spent countless hours showing it what good conversations actually look like. But even after all of this training, the work was far from over. AI still had another major problem. Sometimes it could still generate harmful advice, offensive content, private information, or instructions that should never be shared.
Teaching AI to sound human was one challenge. Teaching it where the limits should be turned out to be an even bigger one, and that created an entirely new hidden profession that most people have never heard about. People whose full-time job was to search for the worst answers AI could possibly give so that everyone else would never have to see them. By this point, AI could recognize patterns, understand language, and hold conversations that felt surprisingly natural. From the outside, it looked ready. Millions of people were beginning to use it every day, and the progress seemed almost unstoppable. But inside the companies building these systems, researchers knew something important. AI wasn't just capable of giving brilliant answers, it was also capable of making very serious mistakes. Sometimes those mistakes were harmless. It might misunderstand a question or confuse two similar facts, but other times the consequences could be much more serious. What if someone asked how to build a dangerous weapon? What if they wanted help committing fraud? What if they tried to generate hate speech, fake medical advice, or convincing scams? The more powerful AI became, the more dangerous its mistakes could become. So a new kind of job appeared. Instead of teaching AI to become smarter, these people were hired to make it safer. Their mission was unusual. Every day, they tried to push AI toward its worst possible behavior. They asked disturbing questions. They invented strange situations. They searched for loopholes. They deliberately looked for weaknesses that ordinary users would probably never think of. Imagine hiring professional hackers to attack your own computer network before criminals can. The goal isn't to destroy the system. The goal is to discover every weakness before someone else does. AI safety teams work in a very similar way. They constantly challenge the model, hoping to make it fail inside a controlled environment rather than in front of millions of users. Sometimes they pretend to be criminals. Sometimes they pretend to be scammers. Sometimes they invent impossible situations just to see how the AI reacts. They ask the same question in hundreds of different ways, because one small change in wording can completely change how the model responds. If they discover a dangerous answer, engineers study exactly why it happened. Then they adjust the model and test it again. The cycle repeats over and over. Most users never realize how much work goes into preventing answers they will never see. Every time AI refuses a harmful request or responds more carefully to a sensitive topic, there is a good chance that someone spent days, weeks, or even months discovering that exact problem long before you opened the app. But creating safer AI is much harder than simply blocking dangerous words. Real conversations are rarely black and white. Imagine someone asking about explosives. Are they a criminal? Or are they a chemistry student? Maybe they're a journalist writing an article. Maybe they're a firefighter learning about industrial accidents. The words alone don't always reveal the person's intention. The same challenge appears in medicine, law, finance, history, politics, and countless other topics. AI must learn to distinguish between helping someone understand information and helping someone cause harm. That balance is incredibly difficult. If the rules become too strict, AI becomes less useful because it refuses perfectly reasonable questions. If the rules become too loose, dangerous answers can slip through. Finding the right balance is one of the hardest problems in artificial intelligence, and it changes every single day because people constantly discover new ways to test the system. This means the work is never truly finished. Unlike a bridge or a building that can eventually be completed, AI is always changing. Every new version introduces new abilities, but those abilities also create new risks. That's why thousands of people continue testing these systems long after they are released. While millions of users see only the polished final product, another invisible team is already searching for the next weakness. But even if AI could become perfectly helpful and perfectly safe, there was still one enormous problem left to solve. None of this intelligence could exist without an unbelievable amount of computing power, and behind every conversation with AI stands a physical world that most people never think about. A world filled with giant buildings, thousands of specialized computers, massive cooling systems, and enough electricity to power entire cities. When you ask AI a question, it feels like you're talking to something that exists nowhere. There is no screen showing giant computers working.
No loud machines, no moving parts, just a text box and an answer that appears almost instantly. It feels weightless, almost like the response came out of thin air. But the reality couldn't be more different. Every sentence AI writes depends on an enormous physical infrastructure hidden from public view. Somewhere, your question travels through the internet to a data center. Inside that building are thousands of computers working together at incredible speed. They are not ordinary desktop computers like the ones sitting in your home. They are some of the most powerful machines ever built. Each one contains specialized chips designed specifically for artificial intelligence. These chips perform billions of mathematical calculations every second, allowing the model to predict one word after another until it forms a complete response. One chip alone is impressive, but modern AI rarely relies on just one. A single request may be processed across many chips working together, each handling a small part of the task before combining the results into the answer you finally see on your screen. Imagine asking thousands of people to solve different pieces of the same puzzle at exactly the same moment. One group works on the edges, another focuses on the center. Others check for mistakes. When everyone finishes, the pieces come together almost instantly. That's similar to what happens inside a modern AI system. Thousands of processors cooperate so quickly that the entire process feels invisible to the user. But all of that computing power creates another problem: heat. A tremendous amount of heat. Every calculation produces energy, and when thousands of powerful chips operate together day and night, temperatures rise extremely fast. Without cooling, those machines would quickly overheat and stop working.
That's why many AI data centers look nothing like the futuristic laboratories people imagine. They contain endless rows of server racks, giant cooling systems, industrial fans, pumps, pipes, and carefully controlled airflow. In some facilities, water circulates through complex cooling systems to carry heat away from the hardware. Every second, enormous amounts of electricity enter the building, and almost every watt eventually becomes heat that must be removed. Keeping these machines cool is just as important as making them fast. A single cooling failure can affect thousands of servers at once, and that's only one data center. Around the world, companies operate many of these facilities, each filled with thousands of machines working every hour of every day. They don't sleep. They don't close at night. Engineers constantly monitor temperatures, power usage, network traffic, storage systems, and hardware failures. If one server breaks, another immediately takes over. If one connection slows down, traffic is redirected. The goal is simple. Millions of people should never notice that anything happened. Most users only see a chatbot answering questions, but behind that simple interface is an engineering system built with the same level of planning and reliability as power grids, airline networks, or global financial systems. Then there are the chips themselves. These processors are among the most advanced products humanity has ever manufactured. Creating them requires years of research, factories worth billions of dollars, and production processes so precise that even microscopic defects can ruin an entire chip. Only a small number of companies on Earth have the technology needed to manufacture the most advanced AI processors. Building one chip is already incredibly difficult. Producing hundreds of thousands of them is an engineering challenge on an entirely different scale. Once those chips leave the factory, they still have a long journey ahead. They must be tested, transported, installed, connected, powered, cooled, and maintained before they can answer a single question. Every response generated by AI depends on that entire chain working perfectly. If the factories stop producing chips, future AI systems slow down. If electricity fails, the servers stop. If cooling systems break, the hardware overheats. If internet connections fail, users lose access. The intelligence that feels so effortless is actually supported by one of the most complex technological infrastructures ever created. And despite all of this hardware, all of this electricity, and all of this engineering, none of it would matter without one final ingredient. None of these machines could improve themselves. Behind every major breakthrough, every new version, and every leap forward still stands the same force that has driven human progress for centuries: people willing to ask better questions and search for better answers. If you could freeze the world for just one day, every AI system would immediately begin falling behind. That may sound strange. After all, once software is finished, shouldn't it simply keep working? That's true for many programs. A calculator doesn't need to learn new mathematics every month. A music player doesn't need to relearn how songs work. But artificial intelligence is different. AI is never truly finished. The moment one version is released, thousands of researchers are already working on the next one. Engineers are improving speed. Scientists are searching for better training methods. Hardware companies are designing faster chips. Safety teams are discovering new weaknesses. Every part of the system is constantly evolving. Standing still means falling behind. Imagine entering a bicycle race where every rider becomes faster every single day. If you stop training for even a short time, everyone else moves ahead. That is exactly what the AI industry looks like today. Every major company knows that improving by just a small percentage can make an enormous difference when millions of people use your technology every day. Sometimes the improvement is obvious. AI becomes faster. It understands longer conversations. It writes better code. It solves more difficult problems. But many improvements happen quietly. Models become more efficient, requiring fewer computing resources to generate the same answer. Engineers discover ways to reduce energy consumption while increasing performance. Researchers invent new training techniques that allow AI to learn more effectively from existing data instead of simply collecting more of it. These changes may never make headlines, but together they push the entire field forward. This race also explains why AI development is so expensive. Building one successful model is only the beginning. Companies must continue hiring researchers, buying hardware, expanding data centers, improving software, testing safety systems, and maintaining enormous infrastructure. The costs don't disappear after launch. In many ways, they grow even larger. Every new generation of AI requires more planning, more testing, and more coordination than the one before it. And competition has become global. Some of the world's largest technology companies are investing billions of dollars because they believe AI will shape the future of almost every industry. Universities continue publishing new discoveries. Startups search for creative ideas that larger companies may have overlooked. Governments invest in research because they understand that artificial intelligence is becoming a strategic technology, much like electricity, aviation, or the internet once was. Progress no longer depends on a single laboratory. It depends on an entire ecosystem moving at extraordinary speed. Yet even with all this competition, one surprising reality remains unchanged. The biggest breakthroughs rarely happen because one genius has a brilliant idea overnight. They happen because thousands of people solve thousands of small problems. One engineer improves memory management. Another reduces the time needed to train a model. Someone designs a more reliable cooling system. Another creates a safer evaluation method. One researcher discovers a mathematical improvement. Another turns that discovery into working software. On their own, these achievements may seem small. Together, they create the next generation of AI. This is why artificial intelligence is unlike almost any other technology. It isn't built once and then left alone. It grows continuously. Every update represents countless hours of invisible work performed by people whose names most users will never know. Every improvement you notice is supported by hundreds of improvements you will never see. And perhaps the most surprising part of all is that this race is still only beginning. Researchers continue searching for new ideas that could completely change how AI is built. Engineers continue pushing hardware closer to its physical limits. New companies appear every year with different approaches and ambitious goals. No one knows exactly what artificial intelligence will look like 10 years from now. But one thing is already clear. Whatever the future brings, it will not be created by machines working alone. It will be built by people, just as it always has been. And once you understand that, the story of AI looks completely different from the one most people imagine. When most people think about artificial intelligence, they imagine the machine. They picture the chatbot, the robot, the software, or the futuristic technology that seems to answer almost anything. But after looking behind the curtain, the picture becomes very different. AI is not only a story about computers, it is a story about people. Every answer begins with human curiosity. Someone asked whether machines could understand language. Someone spent years developing mathematical ideas that most people have never heard of. Someone wrote the code that allowed those ideas to become real. Someone manufactured the chips. Someone built the servers. Someone installed the cables. Someone kept the cooling systems running through the night. Someone labeled the data. Someone corrected mistakes. Someone searched for dangerous answers before the public ever saw them. Someone kept improving the model long after its first release. Every time AI becomes faster, safer, or more useful, it is because thousands of people have quietly solved thousands of problems together. That is why the real story of artificial intelligence is much bigger than one company, one scientist, or one breakthrough. It is one of the largest collaborations in modern history.
Millions of people from different countries, speaking different languages, and working in completely different professions have all contributed to the same goal, even if many of them never realized they were part of something so large. Some work in research laboratories, others in factories. Some spend their days writing software, others repair hardware. Some analyze data. Others design buildings that can support thousands of servers. Most of them will never appear in documentaries, interviews, or history books. Yet every conversation with AI depends on their work. The next time you open ChatGPT or another AI assistant, you'll probably see it differently. Instead of seeing only a machine, you'll see the invisible network behind it. Every sentence represents years of research. Every answer represents countless human decisions. Every improvement represents another problem that someone, somewhere, quietly solved. The technology may feel almost magical, but magic isn't what built it.
Human effort did. Human imagination did. Human persistence did. And perhaps that is the most remarkable part of this entire story. We often ask whether artificial intelligence will change humanity. In many ways, it already has. It is changing how we learn, how we work, how we create, and how we solve problems. But at the same time, AI reveals something equally important about ourselves. It reminds us that the greatest technologies are almost never created by a single brilliant moment. They are created by millions of ordinary moments connected together. One idea leads to another. One improvement inspires the next. One person solves a problem, allowing someone else to solve an even bigger one. Progress has always worked this way. Artificial intelligence is simply one of the clearest examples we have ever seen. Its greatest strength is not that it can generate words, write code, or answer questions. Its greatest strength is that it represents the combined knowledge, experience, and effort of an extraordinary number of people working toward the same future. And that future is still being built. Somewhere in the world, an engineer is improving the next generation of AI hardware. A researcher is testing a new learning method. A safety team is searching for the next hidden weakness. A programmer is writing code that may become part of tomorrow's breakthrough. The story didn't end when you received your answer. It continues every second of every day. The next version is already being built. The next discovery is already happening. And years from now, when AI is capable of things that seem impossible today, the same truth will still remain. Behind every intelligent machine, there will always be an extraordinary number of human minds making it possible. That is the hidden world of artificial intelligence. And now, you've seen what was hiding behind the screen.